Okay, a few more problems. Travis made a business trip of 196.5 miles. He averaged 51 miles per hour for the first part of the trip and 46 miles per hour for the second part. If the trip took 4 hours, how long did he travel at each rate? So, it looks like the way they're splitting this up with the questions, they're saying how many hours for the first part, how many hours for the second part. So the first thing that you're going to set up, the first equation, is going to be pretty quick in that the sum of these two parts gives a total of the 4 hours. So if we go down to the tutor mode, have this pop up, it should give us an option to fill that first equation in, and then we'll have to figure out the second one from there. Okay, my computer was going a little bit slow there. So what I was getting at is x plus y equals 4, where x is the time spent traveling at 51 miles per hour, y is the time spent traveling at 46 miles per hour. And then from there, think about what they're asking you to do. They're saying, you've got these respective rates with these unknown times, and the total distance is 196.5 miles. So it seems like what they're saying is if you take 51 miles per hour times x plus 46 miles per hour times y, each of those give you distances, rate times time plus rate times time. So it should give you the total distance of 196.5 miles. So some problems are like that. You got to kind of know what the relationship is to say something like rate times time is distance. And then also, if I add distances up, I get total distance. That creates that equation there. So from here, the solving part shouldn't be too bad. Again, my computer's going kind of slow here. Okay, there we go. Says correct. And I'll get the solutions for you in just a second. Okay, so I just did a few hen scratches there, and realized that if I multiply the top equation by negative 46, what that will do is cancel out everything in the middle column. It will give me a total of 5x in this first column, and it will give me a total of it'll give me negative 184 and 196.5, which would give you 12.5 as a sum. So 5x equals 12.5. If I divide both sides by 5, you should end up with, I believe, 1.5 when you do the division. 2.5. So 2.5 would be the x value, meaning it would be 2.5 hours traveling at 51 miles per hour. And then if you plug that into the top equation, certainly 1.5 would be what it's left to add up to 4. Okay. Two planes just took off from Milwaukee, Wisconsin. The first plane is traveling 3 times as fast as the second plane. After traveling the same direction for 7 hours, they are 1,925 miles apart. What is the average speed of each plane? Hint, since they are traveling the same direction, the distance between them will be the difference of their distances. Okay. So, as a setup, I think they're still looking for rate times time is distance. X equals the average speed of the first plane. Y equals the average speed of the second plane. So they say, as a hint, the first plane is traveling 3 times as fast as the second plane. How could we set that up as a problem? Well, if the first plane is traveling 3.5 times as fast, we should multiply the second rate by 3.5 to make them equal. Okay, so x is faster. If I multiply by 3.5 with a smaller value, it balances out. Okay, so this could be the first equation. The difference of the distances that each plane travels is in 7 hours is 1,925. So this is kind of like one of the previous problems in some ways, in that if I were to talk about combining distances, say two things were added up and they give you a total distance, that can happen, but also you can have things where there's a difference between the two, and this goes along with the hint that if I went rate times time is distance, so for the faster plane, it's traveling for 7 hours, and its rate is so many miles per hour. So 7x abstractly would be a distance that that plane is traveling. So it's time times rate, or rate times time. But I'm going to subtract the distance traveled by the other plane. It's also been traveling for 7 hours, but it's got its own rate. So there's a distance that I'm taking away, and that should be equal to the 1,925. So I believe this should model this problem here, and it does. And I'm sure with this particular one that the fastest way or the easiest way to solve this is to say if x equals 3.5y, I could actually make a substitution in for x of 3.5y and then just work it out. Okay, so let me work that out on paper quick and I'll let you know what I get. Okay, so after plugging in 3.5y for x, I multiplied it by 7, subtracted the 7y from the product, divided by the coefficient. You end up getting, I believe, because it's for y, the second value, 110. And then if you plug 110 right in for y here, whenever you do substitution, the fastest spot is an equation like this, where you can just multiply by 3.5 and then you'll get the other value, which was x, which was 385. So 385 miles per hour and 110 miles per hour. Okay, there's a couple of problems left here. Not much time on the video. Let's see what we can do. Let's see, I think we can do this one okay. You want to figure out basically in the wording of this problem where this guy works a total of 25 hours between two jobs, $6.40 per hour for one job, $6.90 per hour for the other job, makes $168 a week. If we go to the tutor mode, they want the two equations that you're going to need. If x is the hours worked in job 1, y are the hours worked in job 2, the total is 25, x plus y is 25. Second one, you get the respective rates with each one, so $6.40 times x plus $6.90 times y should give you the total of 168. So that would be the setup for that problem. So using the addition method, I eliminated the first column by multiplying by negative 6.4 on the top. I worked it all out. I actually ended up with a y value of 16, which should give you an x value of 9. So 9 hours worked and 16 hours worked, the two jobs respectively. The final problem just says the sum of two numbers is 47, their difference is 29. Find the two numbers. This problem is quick because it's ready to go with the addition method. Right off you've got a plus x up here and a minus x here. So if I just add the columns right off, I'd have 2x, and then right here, add two columns, you get 76. So 2x equals 76. Divide both sides by 2, you're going to get 38 for the x value. So I should say submit for those two formulas, and say 38 for the x value, which would make the other x value, or make the y value a 9. Just remember, set up two equations based on the wording, and then solve by the methods that we've talked about.